Now we are going to discuss PWM and PPM. PWM means pulse width modulation and PPM means pulse position modulation. Okay, so what is pulse width modulation? That means if we give any basic analog message signal like this kind of signal, this is message signal, and if we varying the amplitude of this signal, then for a pulse generator or a carrier signal generator, that width of the pulses will be varied in accordance with the message signal amplitude. Okay, how it can be done? Okay, let's start. At first we are going to check that this is signal generator. Okay, from this knob we can vary the frequency of the signal like this. Okay, time is varying, that means actually frequency is varying. Okay, now we can vary the amplitude by varying this knob, this vary amplitude knob. Okay, look at this, amplitude is varying. Okay, now these are the two parameters we need to vary. Okay, next is, so this is the message signal. Okay, so we have to set it properly, right? So what is that? We can check it that frequency is 330 Hz and amplitude is 3.5 volt, 59 volt. Okay, so now we are going to check the carrier signal. Okay, this is carrier signal and that is actually the pulses, right? And the pulse frequency, what is that pulse frequency? Actually this is the carrier signal, a square wave signal, okay, which has 50% of pulse width. That means 50% of on time and 50% of off time. That means for this case, what is the frequency here? .28 kilohertz. Look at this. Okay, so this is carrier signal. Now we are going to modulate that pulse width modulation. How it can be done? Let's start. So at first we just connect it at PWM. This is the PWM modulator, this PPM modulator. So we are going to PWM modulated the signal. So for that we are just connected at, this is channel 1. Okay, channel 1, that is yellow signal is PWM modulated signal, and we are connecting the message signal at the signal input. Okay, and then carrier signal to this input. Okay, carrier is inputted and the message is inputted. So now we check how the baseband signal and the modulated signal varying with. That means according to the message signal amplitude, the baseband signal look at this. This is clearly defined that whenever the message signal, the blue signal is message signal here. So whenever the message signal is peak at its amplitude, then the width of the signal will be maximum. Okay, that is T on time or tau, that is maximum. And whenever it is going to decrease, look at this, the T on time is also decreasing, and whenever this is like at the minimum position, the T on time will be tends to 0, right? So that is why this is called pulse width modulation. Okay, so pulse width of the pulses are varying in accordance with the message signal amplitude, right? So now we are going to demodulate the signal. Look at this. To demodulate the signal, what we need to do, that modulated output should be connected to the demodulated. Look at this. This is modulated input. So modulated output will be connected to the demodulated input. Okay, this is modulated. Whatever we have get the modulated output, that is connected here, and that modulated output will be, that demodulated output will be connected at this point. That means a filter circuit is there and another circuit is there to get those two transistors are actually here are connected to filtering the circuit and to get the demodulated output. Look at this. This is the blue one is the baseband signal and yellow one is the demodulated signal. It's almost the same, only a phase difference is there due to the low pass filter. Okay.